In this video we're going to come up with the equation of the tangent plane at this point for this given surface. So this is your ellipsoid. We've got to work out the equation of the tangent plane. So if you jump to GeoGebra 3D, punch in your surface, it will then give us that, and punch in your point 432, which is right here. So our job is to work out the equation of that tangent plane. Okay, so let's jump back to here. So the first step is to work out grad f. So remember, grad f gives you the ability to work out the gradient vector, and the gradient vector always points straight out of the surface. But we want to know the we want to know grad f at this particular location. So first step is to work out grad f. So remember, grad f, take the partial derivative with respect to x. So this whole thing here, so this well, you normally get it in the form of x, y, z equals some sort of constant, and then you can ignore the constant because when you differentiate it, it will be 0. So differentiating this with respect to x, so treat this as a constant, So really, when you take the partial derivative with respect to x, it would just give you 2x, and then this thing here will be a constant, so that would be 0, and this would be 0. So your grad f partial derivative of f with respect to x would be this. And now looking at this whole thing again, take the partial derivative with respect to y. So this is going to be a constant. This is going to be a constant. Well, with respect to y, it would be 4y. And then looking at this whole thing again, take the partial derivative with respect to z. So this would be a constant. This would be a constant. So with respect to z, it would be 6z. It would be 6z. So this is our grad f. Remember, grad f shoots straight out from the surface at 90 degrees. So it shoots straight out. But we want to know at this particular location. So we need to know this vector here at this location. So we need to evaluate grad f at, we need to evaluate it at this particular point. So we've got to put 4 into the x, so that will then give us 8. Put 3 into the y, that will then give us 12. Put 2 into the z, that will then give us 12. So this is grad f here. It shoots straight out from the surface. So if you jump back to here, punch in vector, and then, well, you defined your point a, capital A. So capital A, comma, capital A plus, this is our grad f here at that particular point. 8, oops, hang on, I made a mistake here, hang on. Grad f, hang on. Grad f is 8, 12, 12. So going back to here, it should be 8, 12, 12. So hang on. So hang on. So where is it? So grad, hang on. So this is our vector here. So hang on. So that's grad f there. It shoots straight out from the surface. That black vector there is grad f. Okay, let me just zoom back in. So so now we've got grad f. So now that we've got grad f, so once you've got grad f, then it's easy to come up with the equation of the plane. So you've got your grad f, 8, 12, 12. So this is grad f here, grad f. For this particular point, 4, 3, 2. So now to come up with the equation of this tangent plane, in your mind, picture this. You want to set up the general point x, y, and z. To describe the equation of that plane, you demand that the blue vector and grad f to be at 90 degrees. That's how you would go about describing this plane. So what is the blue vector? Well, the blue vector is given by this. It would be x minus 4, y minus 3, and so on. You demand that the dot product of these two vectors to be 0, because that's when it's 90 degrees. When the dot product of two vectors is 0, that's when it's at 90 degrees. So you make the demand the blue vector, take the dot product of the blue vector and our grad f, and demand it to be at 90 degrees. So now compute the dot product. This times this, plus this times this, plus this times this, and then tidy this whole thing up. It will then give you this. So now if you punch this into GeoGebra 3D, so punch it in. That's this thing here. This is our tangent plane. This is our tangent plane. So you can see it. Well, anyway, play around with GeoGebra 3D and get it working. Okay.